Okay, nice and loud here. Nice and loud. Kaylin, what do you got?
We got the level 1 answer. An object in motion stays in motion.
Object in motion stays in motion. Level 1 for sure, but you won't be alone. All right? Hasmi, what do you have back there? Nice and loud.
Inertia is that something that an object will stay in motion unless acted upon by an outside force.
All right, so they took level 1 and made it level 1.1 by adding that idea of outside force. Maybe 1.05. All right. Sophia, what do you have?
An object in motion stays in motion unless acted on by an outside force.
Level 1.05 again. All right. I think we go to 1.1, maybe right here. What you got, Miriam?
An object's movement is constant until another force changes the movement.
An object's movement is constant until another force changes that movement. I love that for a couple of reasons. Number one, level 1.05 and level 1.051, all right? Forgot about that object that's at rest, right? Inertia pertains to the object at rest as well. But in addition, we didn't address in those level 1s, all right, the idea of how the movement changes or doesn't change. And this idea of constant movement kind of addresses that, all right? Now listen, here's the thing, here's the main thing. Our goal for today and really into tomorrow and weaving our way through the next month is to get rid of, Kaylin called it level 1. I call it the middle school idea of inertia, right? So in elementary school and middle school, you probably, those sciences cycle themselves, right? So you probably had it in 2nd grade, you probably had it in 5th grade, you probably had it again in 6th grade or 8th grade or whatever. Bottom line is that's as far as you got with it in middle school. So then you get to junior year in high school or senior year in high school, and I know what inertia is, and blah, right? Out it comes, that sentence. And I've heard that sentence hundreds of times, right? So you're not alone. Our goal for today and moving forward is to get you to really have an understanding of what it is, not to blurb back that phrase, all right? So that if you're sitting at the cafeteria table, right, Jamie's sitting with a bunch of her friends. They know how smart she is. So if they asked her what inertia was, and she gave them that answer, they'd probably just be like, yeah, Jamie's smart, that must be right. Right? What we really want here is a really correct answer. But we're going to spend substantial time. Again, it'll weave its way in and out of here. All right, but we're going to spend some substantial time. We're going to come back to our desks to spend the next 10 minutes, 15 maybe, really getting ourselves a little bit of a handle on that. All right, so come on back to your desk. We want to go from Caitlin's self-proclaimed level 1 to higher. We got to 1.1. We want to be a 2.0, right? We want to be a 2.0. Okay. So let's start with level 1. Let's start with level 1, right? Object in motion will stay. Level 1 says what? Object in motion will stay in motion. Level 2, level 1.1 says that motion will be what? Constant. An object in motion will stay in constant motion. Now, what's constant motion mean, Anna? Ooh, man, that's level 1.2 for sure. Constant motion means there's no acceleration. What does that mean? Same speed, same direction. All right? Constant motion. Same speed and same direction. Object in motion will stay in constant motion unless acted on by version 1.05 / the middle school version says unless acted on by what, Andy? An outside force. All right, but we don't want to write that because that's middle school and that's version 1.05. Instead, we want to be better than that. and let's talk about this idea of outside forces, right? So we focus on this desk right here. We focus on this desk. Well, first off, here, what's the desk's motion? It's constant. It's constant what? It's at zero. It's at rest, right? So, hey, everything we say here about an object in motion, the secondary part of that would say an object at rest will stay at rest unless acted on. So now we're at level 1.3 because we've talked about an idea of both objects that are moving and objects that are at rest. So here's this desk. This desk is at rest. What does it want to do? Stay at rest. Unless, the middle school version says, acted on by an outside force. Am I an outside force? Yeah, how come?
You're not the desk.
Because I'm not the desk. I'm outside the desk. I'm exerting an outside force, yet the desk is still what? Still at rest. But wait a minute. The desk wants to stay at rest until acted upon by an outside force. I'm an outside force. Why aren't I preventing this desk from staying at rest?
You're not enough force.
I'm not enough force. Jane,
You're not an opposing force.
I'm not opposing what?
The gravitational force.
What direction? Well, that's a correct statement. It doesn't necessarily answer our question, right? John?
You're not like applying any motion to it.
I'm not applying any motion to it. How do we apply motion to the desk? By like moving it. Whoa, that is deep. Let me think about that. I don't know if that's version 1.4 or backwards to like 0.7. All right. What? Look at what's going on. Why isn't the desk moving? Hasmi.
You're just pushing down on it, which is what gravity's already doing, which is what keeping it at rest.
But like I can push more and more and more on it. It's still not moving. Yeah.
Because like the floor.
Because like the floor. Yeah.
Because the floor is also applying force.
The floor is also applying an outside force. So it's not about outside forces. It's about forces that can't be balanced, right? So that we apply movement, right? So what is a force, by the way? A force is a push or pull. That's going to be the focus of our next month and really the main part of the entire course, right? But outside forces are middle school jargon because we can have a gazillion outside. Every single one of us can come up here and push down on the desk. The desk is not going anywhere because the ground is also pushing up. The desk would go someplace if for some reason the ground opened up. And back between Jamie and Sophia, like it has before. There should be like a little circle there that the ground just went whoop, and a kid's chair fell into the thing, right? Yeah, that's the circle. It's been filled back in. That thing just disappeared one day, and the kid went whoop. Oh, it was fun. It was fun. The superintendent didn't think it was fun. Right? So listen, it's not about outside forces unless acted on by an unbalanced force. If I push down on the desk, the floor is balancing my push off by pushing up. If the floor is not there, what's happening to the desk? Boom, it's going down. All right? So get rid of outside force, substitute unbalanced force. Same way here, unless they're acted upon by an unbalanced force. So get rid of outside force, substitute unbalanced force in there. Understand that it's not just about staying in motion. Because look, if I am moving, it is natural for me to stay moving in a straight line. It is not natural for me to like start veering all over the place. Right? Like that's not natural. Natural is, hey, I'm moving, I'm going to keep moving. And if we can go from that middle school idea of what inertia is to an AP physics level, which I think we're going to get to quicker than ever, right? Because I think that we've got a really good grasp on what's going on, and the test results illustrate that. Then we're going to be in really, really, really good shape. But our goal, remember, our goal is to get rid of that middle school definition and really have an understanding of what's going on. And we're going to pick up from there tomorrow, and then and we've already used a couple of big words, right? Acceleration we've used, right? And constant motion. Those things are all going to intertwine themselves in the next few days here to give us a really good handle on what's going on. Okay? So because